Thank you. I am going to talk about domain-specific languages. And I want to tell you a story. But before starting with the story, I would like to ask you to be open-minded about what a language is. Street signs are, in fact, an example of a domain-specific graphical language. The domain here is transportation around the city. This language has its certain rules. For example, the street names are always on the green background, and warning signs are always shaped as yellow triangles, and so on. Another example of a domain-specific language could be musical notation, or, if you wish, a system of signs used by divers to communicate with each other while they are underwater. All of these are domain-specific languages. Let me now tell you a story. The story is completely fictional, but still conveys the important points that I would like you to take from my talk today. And we go back some 21 years ago to the year 1997. And here is John. He has just established a new company. This time, John intends to conquer the publishing market, all by himself. And we're going to consider a particular detail of his business, namely page margins that have to be taken into account before printing documents. For a group of certain pages, it should be possible to specify the needed sizes of margins. Obviously, in one document, there could be many such groups of pages, and so some page enumeration approach would be useful. In our example, it will be single page, a range, and an open interval. When John is having a dinner with his wife to celebrate the starting of a new endeavor, he gets a call from William Smith, who needs to have his local newspaper printed on a weekly basis. John didn't have any piece of paper, so he used a napkin to write down the parameters of the document. What we see on this napkin can be thought of as a domain-specific language for specifying the page margins. Throughout this presentation, I am going to show you several tools that John was using. And I will comment on two things. If you wish, user experience of a tool, and how structured that tool is. Both on scale from 1 to 4, with 1 being the lowest. The first tool was a napkin. So how convenient is that? I think it's 1. How structured is that? I guess a 1 as well. And now we go 2 years further, 1999. With the amount of orders that John has been having, it became clear that he cannot do all this stuff by himself. So he decides to hire a secretary and a typesetting specialist. The workflow is now as follows. The secretary takes an incoming order and sends an email to the typesetting specialist. This is essentially the same domain-specific language as before, but just used in a combination with a tool. Compared to a napkin, this approach is more user-friendly. So that's why 2 points for the user experience. Emails do have some structure, so arguably it's not enough to get a score better than 1 on this scale. 1 year later, and a new millennium. As John's business continues to grow, emails are not the best possible way of communication anymore. So John decides to use Microsoft Word, hoping that it would bring some more structure into page margin specification. John is proactive, though, and he thinks that automation could help his business a lot. He has recently hired Jane, who is a Java developer. Jane has found out that there is a Java library that performs validation of page margins for PDF files. The only thing that Jane has to do now is to write a lot of boilerplate code that uses that library. Here is what the process in the company looks like now. A typesetting specialist uses Microsoft Word to create a specification. This document is then sent to Jane, probably by an internal mail, and she writes Java code by analyzing in her head what is expressed in that Word document. This setting is certainly better than the napkin approach, and there is definitely more structure into the document. And a year later. In fact, before joining John's company, Jane developed software for accountants. She thinks that Microsoft Excel or some other spreadsheet calculator could be used to structure numerous page margins requirements. So she got this idea. What if the typesetting specialist would use Microsoft Excel that has a very particular layout of cells, and then Jane could programmatically analyze that file and generate the boilerplate Java code. Let's have a more detailed look at the layout of cells here. A specification starts with the cell that contains words for pages. Always spans for 9 columns to the right and spans to the bottom until the end marker, which is 3 consecutive minus signs, is found. In this layout, for example, the value of the right margin is always located in the cell that is 6 columns to the right and 1 row below the starting marker cell. What is very important about Excel approach is that we can perform some validation of the values entered by a user. For example, when an interval is specified, its left part should be strictly less than its right part, and so on. Because there is domain-specific error support, meaning that errors appear where the problematic regions of code are, this approach gets a high score both for user experience and for how structured it is. It becomes more and more difficult for a typesetting specialist to define something in a wrong way. Yet another year elapsed. In the meantime, John's son, Andrew, is already in high school and is interested in computers. So for a nice remuneration from John, Andrew has developed a simple web page for his father's business. When a user clicks the Submit button, the already usual Java boilerplate code would be generated and automatically sent to Jane. This approach wasn't, however, introduced into John's company. When John talked with his typesetting specialist about this approach, they all told that they were very happy that in Excel they could simply copy and paste some cells. Clearly, in Andrew's approach, one would have to click the Add button and couldn't easily copy the values of different margins. And again, one more year. Jane decided to try XML and the stack around. The specification document would now be in XML format, and the typesetting specialist becomes a developer, him or herself. Jane has implemented an XSL transformation that generates the old, good Java boilerplate code from the XML document. Documents are validated with an XML schema, and a suitable tool support can show error messages in where they are. This approach is by far the more structured one. If a document has wrong structure, it will not be validated. User experience scores the worst. Typesetting specialists have to learn XML editing tools, and they are perplexed by the XML's syntactic noise. John's business is growing incredibly well. And Jane has been developing a lot of stuff for the company. But the page margins requirements were still done in Excel. Everyone got used to them and was very reluctant to change anything. However, Jane has heard about a new programming language, Clojure, and about domain-specific languages. Jane Googled a lot phrase domain-specific language. She found out that there are two kinds of them, internal and external. Internal languages, as they say, are very easy to build and maintain. Essentially, you just use some programming language in a very particular way until it starts to have a convenient syntax. What convenient means here depends on who is using the language. And Jane wanted to make a language that her typesetter colleagues would be able to use by themselves. So she essentially wanted to make a language for non-programmers. This idea turned Jane to external DSLs. They would give Jane an absolute freedom of syntax. There was, however, one issue. Implementing an external DSL with custom syntax requires writing parsers. And she didn't know how to do it. And she wasn't willing to spend a lot of time on that. So Jane decided to go for an internal DSL. That's how she imagined the process. A typesetter would write code in Clojure and compile it into Java boilerplate, the same way it has been done for many years at the company. Here is a sample code in Clojure DSL developed by Jane. Error messages are cryptic for a typesetting specialist It's here assert failed. And it is still possible to make mistakes in the structure of a document, like I have double right specification here. So if you want to take one thing from my talk today, it's this. DSL without tailored IDE will not be used. So if you want your DSL to be used by non-programmers, then you should provide a custom IDE for your very language. And I mean it, using Clojure's IDE is not enough. You need your own IDE. So how do we do it nowadays? Or how would we do it nowadays? Obviously, creating from scratch a professionally looking IDE for a custom language is a very difficult job, and it's also thankless. Here's why we have new tools for creating languages and tooling for them. That is, tools for creating tools, that is, meta tools. Those are called language workbenches. A particular example is MPS, an open source language workbench developed by JetBrains, the company behind IntelliJ IDEA. What if you could get an IDEA level custom IDE for your language by clicking a couple of buttons without needing to write a parser? Languages implemented with MPS can feature rich notations, and the automatically generated IDEs provide custom autocomplete. For example, here we have measurement units for page margins, and intentions, also known as quick fixes in Eclipse world. All of these are domain-specific, that is tailored to your particular language. And error messages, they are also domain-specific, and they communicate exactly what's the issue in the code. It's wrong page interval, not assert failed. To allow this syntactic freedom, MPS uses a projectional or structural editor. The user edits not the textual code, but rather the abstract syntax tree of it. And these trees can be projected into text, tables, and graphics. Textual form of code is only meant for the programmer, and no parsing at all is required when a projectional editor is used. Here is how code generation works. We just select the document, click Preview Generated Text, and that's the Java code that we've got from our DSL. If we change something here and have a look at the regenerated text, it got changed. So can we say that MPS is always better than Excel? Didn't we lose something? In Excel, we kind of could define variables and use expressions, and it wasn't present in the language that I have just shown. The solution to this problem is actually to embed an expressions language into our page margins domain-specific language. And this is how it would look like. So I can define variables or values that use expressions, and then I would be able to use those variables here when specifying page margins. Let's see. Yep. And I want to make a point about what embedding exactly means here. Many people refer to internal domain-specific languages as embedded languages. This is not what I'm talking about here. What my point is this. Here we have a Scala code intermixed with XML. This has kind of the right flavor of what I'm talking about, but Scala was built like that since the beginning. XML support is actually a part of Scala language. What I'm really talking about is non-invasive embedding. It's when we have a language A, and without changing it, we could mix it with some language B that doesn't change either. Sounds like magic, right? But MPS allows you to do so seamlessly thanks to its projectional editor. And the expressions language that we are going to embed in our page margins specification language is called KernelF. It has been developed by Markus Felter and a team of German consulting company Itemis. KernelF is a functional language with static types and type inference. Unlike other functional languages, KernelF has many first-class constructs. This is motivated by the wish to make KernelF accessible to non-programmers. Apart from standard things like primitive types and arithmetical expressions, KernelF features option types for null values and attempt types as a mechanism of exception handling. Because KernelF is not designed for building abstractions, it does not have algebraic types. The language into which KernelF is embedded should take care of that. Here's sample code. The language has natural notation for mathematical expressions and features, for example, Excel-style spreadsheets within user's code. Now I will talk about the language itself. Instead of usual types for integer and float point values, KernelF has number type that specifies range and precision. Here we have, for example, a decimal with 2 decimal places, values between 10 and 20. An interesting feature of KernelF is so-called type tags, also known as type qualifiers, that can be attached to types. Consider a function display that has only one argument, which is of type string. In KernelF, we can express the requirement that this string should be capitalized by attaching a tag to type string. Of course, we will have a separate function to all upper that capitalizes a string and returns a string with capitalized tag. Now another example. We want to classify strings into 3 different categories: easy, normal, and hard, with each following category including the previous ones. For that, we define 3 tags: easy, normal, and hard. And now we can specify exactly what kind of text can be published in Twitter, for example, and what kind of text can be sent to a professor or printed on a T-shirt, depending on their complexity. Option types are for tackling null values. They are similar to maybe monad in Haskell. KernelF provides an interesting way of dealing with exceptions through so-called attempt types. An attempt type mentions a type of the value that the function should return, and several error literals that represent, if you wish, possible errors. Here we have a function getWeather that returns a number with a value from -40 to 40, given a city name, and city name is a string. The type of this function mentions 2 error literals, so 2 possible exceptional situations: timeout and not found. When this function is invoked in some other function, we use a try block, where instead of catch blocks, we specify returned values of the function display degrees if a corresponding exception is thrown. KernelF is a flexible language. You can add new constructs to it, and they will become first-class citizens of the language. But Lisp-style languages have a long tradition of being extensible via metaprogramming and can be used for creating internal DSLs. Their syntax is, however, too difficult for non-programmers to adapt, and they only allow for textual languages. And it's not easy to make an existing IDE aware of the new extensions. Unlike Lisp-like languages, KernelF uses the power of a language workbench MPS to address these issues. Apart from adding new constructs to KernelF, it is also possible to remove existing ones, to replace primitive types with some other ones, or even to define new syntax for existing constructs. Here we have a function accelerate with some arguments. Here's how we invoke this function. Nothing unusual. However, business users might not easily perceive positional arguments with parentheses, so it could be beneficial to provide call syntax like this: car.accelerate to 10 with 2. In KernelF, you can define an alternative call syntax for a function using syntax annotation. What is particularly important here is that as soon as the annotation is defined, it appears in the autocomplete menus. KernelF is a functional language, and no expressions have side effects. This means that it is possible to cache the results of function calls when they are called with the same arguments. Because KernelF is extensible, it may happen that new expressions have side effects, or KernelF may be embedded into a language with side effects. So one has to know the functions that can be cached and those that cannot be cached. This is done by effect tracking. KernelF distinguishes between read and write effects, and for write effects, it also tracks idempotence. That is, whether a function can be applied multiple times without changing the result after the initial application. When you have immutable data, you can't change any value after its creation. If you want to change that value, you will have to create a new temporary name to hold the new value. Assume you have a list of 3 integers, and you want to add a 4th element to it. So you have a value A with the original list, and you introduce a new value B that holds the new list. Works fine in this case, but what if you still want to update the original list? You can surely use variables instead of values, mark the addition operation to have an effect, and so on. But the problem is that element addition function does not exist for mutable collections. And so you need to have a version of that function for mutable collections. This is the case, for example, in Scala. KernelF encourages using boxes. The box itself is immutable, but its contents can change. Boxes have 2 operations: val that returns the contents of the box, and update that sets a new value. When you update the contents of the box, you in fact pass a new value. So KernelF was designed as a language accessible to non-programmers with the intention to make writing correct code as simple as possible. First-class constructs can be added or removed from the language, and the language itself can be made a part of some already existing another language. That's it from my part. Thank you.
Yeah. Questions? There?
I find this very, very interesting, this presentation.
Thank you.
I'm kind of perplexed about the approach to make non-programmers, enable non-programmers to create precise specifications or something like that, because in my experience, the main problem is usually that they can't write text, but other kinds of tooling, like, for instance, how these specifications are edited collaboratively. Yeah. Like the version control is a main entrance barrier for many managers, and so kind of. As I kind of see value in making it textually easy for non-programmers to create this text, I think it's even more important to introduce services that enable non-programmers to edit them collaboratively and see the differences between versions and stuff like that. That's where, in my opinion, the kind of non-programmer side is hurting a lot. Like, yeah.
I absolutely agree. It would be, of course, fantastic if you could have like a Google Docs style, collaborative editor of code. There is some stuff to do in this field. Definitely.
There is some research at Tampere University of Technology on that, for example, like Google Docs style code editing and real-time chat on the side.
Thank you. Well, this talk was mainly about IDEs. in their like traditional definition. What you are suggesting, guys, is like kind of, you know, moving further away from like programming, and that's I think it's a topic of a different research.
So, okay, great talk. Thank you for that. I have a simple question, or not simple, but it sounds simple. When does a DSL stop being a DSL? Because the language that you presented, while certainly having a domain in mind, is pretty much a general purpose language. It seems as if you can do anything with it.
The point is that, for example, here in the page margin specifications, we embedded the whole KernelF, and we were able to use variable declarations, expressions, and so on. But it is also possible to embed only some part of KernelF, like only expressions. And then you will have the page margins language, which is by no means a general purpose language. And then just here you would write like, you know, 2 plus 3, without variables, without values, without functions, without anything.
Right.
Hello. So how does it work behind the scenes? Does it run on top of JVM, or how does it work?
So essentially, MPS is a language workbench. So it means that the whole development experience takes place there. Behind the scenes, MPS is developed using Java, and whatever your domain-specific language you define, you can define a converter, so to say, to Java or to other languages. The point is that the users of the domain-specific language do not have to care about the backstage, so to say. For them, it's just an IDE.
So how does the converter defined in what language?
Also within MPS. So you have a special language for defining code generators.
Okay, okay, understand. Thank you.
Thank you for the talk. Very interesting. DSL, I think, is very. I'm here.
Where?
On the top. Yeah.
Aha, yeah, sure.
Yeah. It's very interesting, promising, because there is so much domain knowledge, and it can be used by specialists. So not every programmer can do this. Scuba diving knowledge or some nuclear fission knowledge may not have it. So, but I'm asking. The question is, there is other workbench tools, open source or proprietary. How do you measure with them, and can you export import this? Because there is already some work done, and there is also, for example, eText in the Eclipse world.
Xtext.
Yeah, Xtext.
Yeah.
And there is some implementation. Can you export it or import, or should you implement it from the?
Unfortunately, you cannot export because MPS does not support textual editing. It's a projectional editor, so it's from a completely different world than Xtext, for example. Theoretically, you could define a translation from the MPS internal representation of language to Eclipse a modeling framework, which is the basis of Xtext. But theoretically it is possible. But in reality, if you want to switch a tool for your users, you have to re-implement the language.
Okay, thank you.
Thanks, great talk.
Thank you.
Some people have said that kind of Excel is the first kind of programming language that has become, that is used by general people, not specifically for programmers. Have you had any thoughts about how you go from Excel to this?
For example, here in here, we have it's a example of a spreadsheet embedded into code. So when you try to explain to your domain users that this is kind of Excel but a little bit different, and they get used to this, then it's easier to actually switch them to real code. But Excel is the most popular functional programming language in the world.
That's a good closer. Thanks a lot, Mikhail.
Thank you.